Welcome to the lecture portion on precipitation reactions. We are talking about chemical reactions still. And so this is one of the types of reactions that's really kind of fun to see. One of the reasons for that is because it actually makes something that you can see, which is to make a solid. Precipitation reactions occur when two solutions get mixed together and a solid forms. So let's say that we combine a solution of lead nitrate, PbNO3, and sodium iodide, NaI. We want to know what ions can form or are formed initially, what can combine in solution, and then we check to see, well, what can we make, what can we form, and we see if any of those can actually make a precipitate. And those solubility rules are in table 4.1 to see if something is insoluble that can combine. So we see that we have initially in our lead nitrate solution, we've got lead ions, we've got nitrate ions, and nitrate compounds are fantastic to try to dissolve in water. There are no nitrate compounds that don't dissolve in water, dissociate in water. So they're very good for making solutions. We also have a sodium iodide solution here. Any group 1A compound, so anything with lithium, sodium, potassium, also dissolves in water and dissociates into ions. So those group 1As are also very good for making solutions. So when we pour these two solutions together, we have lead ions, sodium ions, nitrate ions, and iodide ions. So the only possible combinations that are new, that are feasible, are the lead and the iodide, the sodium and the nitrate. Obviously, we wouldn't want to look at the lead and the sodium. They're both positive ions, cations, so those aren't going to combine. And with the nitrate and the iodide are both negative ions, so they're not going to want to combine. The lead and the nitrate were already together in solution, as was the sodium and the iodide, so they're not going to combine and do anything different in this solution. So the only possible combinations that we haven't seen are lead and iodide and sodium and nitrate. So we would check our solubility rules and see, do we expect any of those to form? And what we see is that when lead and iodide come together, they form something that is not soluble, and that is lead iodide, PbI2. And we see an example of what PbI2 is here in our flask. It's a bright yellow solid that is insoluble in water, and so it forms a solid and it does not dissolve, and that's what we call a precipitate. Now notice that even though we just have the one iodide from sodium iodide, when it combines with the lead, we have two iodides. So you always have to be careful with the chemical formulas. The formula of what it went in as is not necessarily the same with what it's going to precipitate as. You just need to look at the charges. We've got lead here with a 2+, iodide with a 1-. So when those two ions come together, I need two iodides to combine with that lead in order to get a zero charge. Anytime you have a solid, it will always have a zero total charge. Now, what about the sodium and the nitrate? Well, like I said, nitrates are always soluble. What that also means is that they will never form a precipitate. The same goes for sodium ions, any group 1A ions. Anything that always dissolves will never form a precipitate. So nitrate ions, acetate ions, group 1A ions, those kind of things never form precipitates. So since we get a solid precipitate formed here, we call this a precipitation reaction. So where did those other ions go, the sodium and the nitrate? We know that they didn't form a precipitate because we see them floating around in solution. We mentioned that the solubility rules say that all sodium compounds are soluble and all nitrate compounds are soluble. So we can look at that in two different ways. We can look at any salts that have nitrate ions or sodium in it will always dissolve in water, but it also means that those ions will never take place in a precipitation reaction. Okay, they will never form a precipitate. So we call those types of ions spectator ions. Basically, they're like your parents who, when you were a child, would bring you to a football competition. You would go play. They would go up in the stands and and watch. They were at the competition, they were there, but they didn't actually participate. And that's kind of what the sodium ions and the nitrate ions do here. So we call those spectator ions. Mention that, do not take part in a reaction. They do continue to be dissolved in solution. They are still there. They are still in the solution. And if we are to evaporate the leftover solution, if we were to take the solid out and then evaporate all of the water off of that solution, then we would end up with a sodium nitrate crystal once all the water is gone. So they are still in solution, but they're just dissolved. They're dissociated. Now, when we write precipitation reactions, we have different ways of writing them. And you always want to make sure that you know what you're being asked for so you know how to write the reaction. So here's one way we can write this reaction, and this is called a molecular equation or a complete molecular equation. All of the species are written as molecular formulas. Okay, so the lead nitrate, even though we know that it's dissociated into lead ions and nitrate ions in solution, we still write it as lead nitrate. The formula is lead nitrate. We do put a little AQ after that, and what that means is aqueous. That tells me that that compound is broken apart in solution into lead ions and nitrate ions. And then we see the same thing here for NaI. We know that the sodium ions and the iodide ions are no longer together in solution. They are also aqueous, but we still write it as NaI, and we say it's aqueous to let a reader know that we know those are in solution and not together. Now, in our product here, we have PbI2, and we put an S after that because that is, in fact, a solid. So lead iodide is a solid. And here, even though the sodium and the nitrate remain in solution as spectator ions, we still write the formula as as sodium nitrate to indicate that, and we put the AQ to indicate that those are still in solution. They are not together as a compound. They're floating around in solution, but we could retrieve sodium nitrate from that solution if we were to evaporate all of the water. Okay, so we call this a molecular equation. Notice the charges. Again, we have just one single iodide here. We have two here, so I've got to balance that with two sodium iodides here. And so that the formula over here for the nitrates gives me two NO3s, and I only need one NO3 with it. These NO3s here are not bonded together. It just means that I have two NO3 ions in solution, a nitrate ion. So the sodium only needs one of them, but I have two sodiums, I have two nitrates, and so I have two sodium nitrates in there. That's a little confusing at times. If you have questions on that, make sure that you get some help. Okay, second way we can write the equation here is something that is called a complete ionic. And what we've done here is anything that we know is dissociated in solution, we write as separate ions. Anything that's together in solution, such as the solid, we still write as a molecular formula. So our PbNO32 becomes a lead ion and two NO3 minus ions. Okay, notice that I did not write that as NO32 ion. It's two different nitrate ions, so two NO3 minus. Okay, and we still write aqueous. Same for the sodium iodide. I have two sodium ions, two iodide ions coming from here. Okay, then in the product side, I've got PbI2. That hasn't changed. It's still a solid. It's not broken apart into its ions, and so we still write that as a molecular equation there. And then the sodium nitrate, we said, is actually present as sodium ions and nitrate ions, and so we have two sodium ions and two nitrate ions from the two NaNO3. So that's a complete ionic equation. And then the last one is something that is called a net ionic equation. This is where we have taken the spectators out. Okay, so this should say spectator ions. Okay, so we've taken the spectator ions out. You find the spectators by locating any species that was present in both the products and the reactants. So we see you've got two NO3s here and two NO3s here, so we can cross them out. Kind of like algebra, we've got two sodium ions and two sodium ions. So the only thing that we're left with is the lead ion, the two iodide ions forming Pbi2 solid. So that is the net ionic equation. That is the chemistry that took place when those two solutions were mixed together, and so that's your net ionic. So here's one for you to try. I want you to write the molecular equation, complete ionic equation, and net ionic equation for this precipitation reaction. So you've got aqueous solutions of barium nitrate and sodium carbonate. So check your precipitation tables or your solubility tables to see what can form a precipitate. You can see how those particular substances might break apart. So give it a shot, and a link to that will be posted in Canvas to a YouTube video.